Hello and welcome to this short tutorial on the AIM Review tool. AIM Review is a web application developed by researchers at King's College London. It uses artificial intelligence to accelerate the screening process in systematic reviews. The tool runs directly in your browser, so there's no need for complicated installations or setup. AIM Review follows a modular structure, where each step of the systematic review process is handled in a separate module. In this video, we'll be focusing on the labeling application. This is the part of the tool used to load your literature from databases like PubMed or Web of Science, remove duplicates, and begin screening titles and abstracts using your inclusion and exclusion criteria. To get started, follow the link provided on the screen or in the video description. This will take you to the AIM Review homepage. On the left panel, under Applications, you'll find a tab called Labeling Application. Click that to enter the module and begin. For a systematic review, the first step is to search and export the relevant literature from databases such as PubMed, Web of Science, or Scopus. The exported files vary depending on the source, ranging from Excel spreadsheets to RIS files or plain text. In this tutorial, we'll be using 3 PubMed text file exports and 3 RIS exports from Web of Science. However, the labeling application supports multiple formats, as long as the files contain titles, abstracts, and a document identifier like a DOI. If you'd like to follow along with the demonstration, you can download the example files from the Google Drive link in the description. Once inside the labeling application, you'll begin by configuring how files are loaded. Select the appropriate file type, in this case PubMed text files, then choose the files and press Import. This will bring in the titles, abstracts, and DOIs from the selected files. You'll see a summary of how many entries were successfully imported. To add files from another source, such as RIS files from Web of Science, simply update the file type in the configuration, select the new files, and import again. The application also shows a donut chart to help you keep track of how many entries were loaded successfully, how many were duplicates, and how many were excluded due to missing information. If some entries are missing a DOI or another identifier, you can enable the option to fill empty entries, which will assign a random ID to those records to prevent them from being discarded. Once all the literature is loaded, you can choose to screen a random subset of entries if you'd like, for example, 20% of the data set. Then, by clicking Start Labeling, the application will begin displaying the publications for manual review. The labeling interface is simple and intuitive. You can move through the publications using forward and backward arrows, and label each one as either relevant or irrelevant by clicking the corresponding icons. You can also adjust the font size, sort publications alphabetically, and define relevant or irrelevant expressions that will be highlighted in the text, green for relevant, red for irrelevant. For example, you might highlight terms like psychosis or diffusion tensor imaging as relevant and conference proceeding or systematic review as irrelevant. As you label publications, your progress can be saved at any time by clicking the Save button. This will download an Excel file containing your labels. If you close or refresh the page later, you can simply upload this file again to continue where you left off. Let's show that now. But instead of using the random labels we just extracted, we'll use the Excel file shared earlier in the Google Drive link, called labeling.xlsx. This file contains screening labels generated using Gemini's large language model, based on the inclusion criterion. Does this publication use machine learning to produce or evaluate a diagnostic or prognostic model in mental health? In this file, a yes label is represented as 1 and a no as 0, covering about 20% of the publications we previously loaded. Loading this file into the application simulates the situation where you've already screened around 20% of your entries during a previous session. We'll now load them back into the labeling application. To do this, we refresh the labeling window either by clicking the Reset button or refreshing the Browser tab. Then, we open the Load Config window, select Output Labeling File, choose the labeling.xlsx file, and press Start Labeling. Once this is done, the application will load the saved screening progress. Keep in mind that the labeled entries appear in random order, not sequentially, so you may need to scroll to around publication 11 to see the first labeled entry. As mentioned before, about 20% of the publications have already been screened. Now, we'll apply active learning, a machine learning approach that learns from the labeled entries and assigns a relevant score to the remaining ones. This relevant score is used to reorder the publications by how likely they are to be relevant, helping you prioritize the most promising papers for manual screening. Before we do that, we need to configure our machine learning settings. There are 2 or 3 main options to select. First, the text vectorization method. This determines how the titles and abstracts are converted into numerical representations of the text. Second, the classifier type. This is the model used to predict the relevance of each entry. And finally, if more than one vectorization method is selected, the ensemble method determines how the vectors are combined. If you're curious about the details of each method, you can find more in the documentation. For now, we'll go ahead and choose a configuration. We open the mlconfig window and select 2 vectorization methods, tfidf and LSA of tfidf. We'll keep logistic regression as the classifier. Then we open the ensemble config window and select fusion, and in the active learning panel, we choose to display relevance probabilities. After this, we close all modal windows to return to the main application. So what have we selected? 2 fast and efficient vectorization methods. tfidf, or term frequency inverse document frequency, transforms the text into vectors by assigning weights to each word based on how often it appears in a document compared to its frequency across the entire dataset. This helps surface the most important words and downplays the common ones. It's simple, fast, and effective. LSA, or latent semantic analysis, applies dimensionality reduction to the tfidf vectors using something called singular value decomposition. This helps capture underlying semantic relationships, allowing the model to understand the context of words rather than relying only on frequency. We've chosen to fuse or concatenate the output vectors from both methods. Then, we use logistic regression, a fast, shallow learner, to predict the relevance of the publications. Once everything is set, we click the Active Learning button. Inside the mlconfig, we go to the vectorization panel and confirm that both vectorization methods have been processed in less than a second. We then close all modal windows to return to the main view. Because we've selected fast models, the relevant scores are calculated quickly. In the main labeling application window, you should now see a relevant score ranging from 0 to 100% next to each publication. You also see a plot showing the distribution of scores across all entries. You can explore the publications by scrolling or clicking on bars in the plot to jump to specific entries. And if you want, you can recompute the relevant scores at any time by pressing the Active Learning button again. To sort the publications by relevance, we head to mlconfig, then into the Active Learning panel. We set the reordering option to highest relevance first, and then close all modal windows once again. After pressing the Active Learning button one last time, the interface will reorder the unscreened publications based on predicted relevance. Screened entries appear at the beginning, while the unscreened ones follow, sorted from most to least relevant. This helps you prioritize what to read first, focusing your attention on entries with the highest chance of meeting your criteria and leaving the likely irrelevant ones for later. Feel free to test other vectorization and classifier options within the application. While this tutorial uses fast, shallow models, the tool also supports deep learning options like sentence transformers and neural networks. Just keep in mind that these more advanced models will take longer to train and compute relevant scores. And that brings us to the end of this short tutorial on the AIM Review labeling application. For a deeper dive into all configuration options, don't forget to check out the documentation page on the AIM Review website. If you have any questions, feedback, or spot a bug, reach out. We'd love to hear from you. We hope AIM Review helps you and your team save valuable time in your systematic review process. Be sure to explore our other videos, where we walk through the different modules of AIM Review, and stay tuned for upcoming workshops and seminars. Thanks for watching, and happy reviewing!